And so biggest reminder is there's no school Friday. Whether you're blue group or green group, doesn't matter. There is no school Friday, but your homework is still due. So I could have made it due tomorrow at 4:30 since there's no school Friday, but I figured you can do that on your own. If you want to make your due date tomorrow at 4:30, that's up to you. But I might check things Friday evening, or if nothing else, Khan Academy will let me know if you did it on time or if you did it late. And again, I can go look at exactly when you did it if I want to. Last call to turn in masteries. Hopefully we already have all those. And then like I said, if we have time, we will play a game in Desmos, another new one. I think it's pretty fun. So, solving a system. Yesterday we talked about these things. And I want to make sure I can't see everything on my TV because it's a slightly different size. So this is what we talked about yesterday, and if you want to rewrite this process, if you forget what the process was from yesterday, you might want to write down the 1, 2, 3, 4, that order there. But at a minimum, let's start our notes by heading our notes with solving systems algebraically. I think, says your math teacher, I think it is, oh, my camera's way up there. I think algebra, algebra, but algebraically, I think. Now remember today's date. Now for those of you watching this video tomorrow, your date will be 10/15. Hopefully Mr. Johnson got you guys set up reading the directions and knowing what you're supposed to do. I'm going to try to make this video as efficiently as possible. Try to be done with it here in about 30 minutes so that we have time to play some Desmos. But yeah, as we talked about yesterday, and if you guys weren't at school yesterday, it was probably 2 days ago, or, hopefully. When we solve, this goes back to our game that we played in Desmos with the hangers, right? So that hanger game, what we ended up doing in the notes that we took was we chose a side for the variables and put them over there. And we did that using inverse operations. We did that, we chose the side by looking at the highest value, right? What side has the highest variable value? Then we combine variables using inverse ops. On the other side from the variables, we combine constants. And then we solve for x using multiplication or division. So let's go ahead and write down the first problem that we're looking at here. So 4a plus 5 equals 2 plus 3.25a. Now where this is different is now today we're adding in fraction values and decimal values. So you'll see, again, we're going to start easier and keep ramping up to harder and harder problems. So if we do step 1, and guys, I'm just going to kind of go around the room and call on people. So remember, you can pass if you want to. So might as well pick on Logan because he's always a good place to start. Logan, which side would have the higher variable value, left or right? Left. So that's our step 1. We determine left side has the higher variable. So then step 2, I can kind of do step 1 and 2 at the same time. What do I do to group the variables on the left side? Colin? Yeah, we subtract 3.25a from where? Both sides. So if you want, you can draw this dotted line down the middle to remind you of both sides. Just however, we can always keep extending it. So you'll notice I write my in-between steps in a different color, and then I write the equation in blue, or at least the same color that I've been working in. So this subtraction, 0.75a, do not try to combine steps while we're learning how to do this. Later, you can combine steps and do multiple things at once. Don't do that yet. So, huh? Probably a little bit, yeah. Especially if your 7th grade teacher was trying to push you guys. One-step equation solving is for sure a 7th grade standard. This is now technically called multi-step equation solving. So this was one step, right? And we're obviously not done. Our one step that we did on both sides was subtraction of the A value. Sebastian, we kind of skipped over you making the loop around the school, or loop around the loop around the classroom here. So Sebastian, when I look now for what side is my constant side, what side is going to get the constants? Yeah. You're right. To make sure that we answer the question I was asking, if the left side has become our variable side, then the right side is going to be our constant side. So since we decided that the left side was the variable side, the right side is our constant side. So that's why we do that subtraction. We use the inverse operation. And we do 0.75a equals, negative 3. Now, there are actually two ways that this might be written, but since we're working with decimals, let's just go ahead and keep going that way. We're going to keep going across the back of the room. So, Hannah, can you tell me, guys, remember, you can always pass. Can you tell me what we should do here? Yeah, I can barely hear you guys. I need to go turn my thing down. But now we divide, and this is that sorry, we did step 3, right, combining the constants. And then step 4, the solving for x, 0.75 is multiplied to it, so we're going to divide by the 75/100ths, and we do it on both sides. Now, this is something that a lot of times kids will come to me and be like, this doesn't make sense, but it does. If you divide by a number less than 1, your answer gets bigger. So grab a calculator, or if you don't, we're going to have to utilize a friend who has a calculator on them. What is negative 3 divided by 0.75? You're on it? What do you mean, no? She beat you to it. Now, the other way we could actually talk about this is negative 3 divided by 3/4. And this is where I think Sebastian is getting his answer. We could actually keep, change, flip this. So if we keep, change, flip, this actually becomes multiplication. Sorry, I should not have written that division symbol. And the 3's on top and bottom cancel out with each other. But it's not just 4. I couldn't tell if you were saying the negative or not. It comes out to be negative 4. Ooh, that's because you're using the wrong button. The negative button, this is a good reminder, so I appreciate that you said that. This is not the negative button. This is. Down at the bottom of the keypad, that's why it's in parentheses. That's your negative button. This is minus. So if we wanted to do, that syntax error will happen if you do that. So if we wanted to do negative 3, I hit this button down here, negative 3 divided by 0.75. No, it's not. Look, minus immediately wants me to take something away, right? Minus is saying I'm subtracting from something. So if I hit minus, it doesn't work. It literally wants to grab another number and put it in front of it. If I hit negative, it will. It'll let me actually do the math. It is not the same. I guarantee you, I will bet my house on it.
It works the same on Desmos.
Well, yeah, because Desmos has to deal with the keyboard not having so many buttons as a calculator does. So you are correct. It works the same on Desmos, but that is not the same as all of our handheld calculators.
But it is a scientific calculator.
Does anyone have any questions on what we just did? Because if not, your next problem is this, utilizing fractions. I'm not going to show my writing for for a couple minutes, but I will tell you, Brittany, Sophia, Dewan's not here, so Audrey, you guys are my next people. I'm just kind of making a loop of the classroom, so you'll be my next people to call on. You can talk with each other right now, too. So if you don't know how to start solving this, feel free to ask classmates. I'm going to work on my paper for a minute while you guys work on yours. People watching this video tomorrow, well, it'll be today for you, but people watching this video on Thursday, you should try this on your own and just let the video play. I could sing you a little song if you want while you solve it, but I don't think that will be helpful.
Yeah.
There's a song that you'll learn. Well, you might not learn it because I won't be your teacher, but there's a song called the Quadratic Formula song that is like, negative b plus or minus the square root of b squared minus 4ac all over 2a. Like it's all math, and that's my funniest song because it's not really a song.
Please keep going.
If we think about rule 1 or step 1, I hate saying rule.
But it is a rule.
Kind of. If we think about step 1, Brittany, when we look at our equation here, and you don't even have to look at the one that I have written, you can look at the cleaner one up here. What side has the higher variable value? The what? So this is actually, I get why you're saying that. This looks like minus right now. So I love that you said, yeah. So now, right, Brittany, remember, that's a negative. So if we want to rewrite this, this is actually 20 plus negative b. Now, we could use the right side as our variable side, but it's going to get more negative. So unless we want our equation to become more negative, we're going to choose the left, side because it's positive. If you have a negative and you have a positive, choose the positive side. So, Brittany, we're going to say we did that on purpose because that was a great teachable moment. So I really do appreciate that you said that. Be careful of the minuses that are actually negatives. So if I add b over here, I got to add b over here. Now, wait. Since this is a fraction, how many b am I adding over here? 1. If I want to make 1b into a fraction amount of b's, are you trying to go to the bathroom? Yeah. All you got to do is like tell me bathroom, e-hall pass. And approved. Now I don't know what I was looking at. I don't think it mattered. How many what's over what's should I put to make 1b given what we see on the left side? We'll go Sophia because I was coming to you next.
5/3.
Oh, you're jumping to the answer. Be careful. 1b, I know how you got there, is 3/3 b. So we're adding 1b, but that's what 3/3 b is, and that's how you got your answer. Be careful if you jump to the answer. A lot of times am asking for the process. 5/3 b plus 5 equals just 20 on the right-hand side now, right? Because the negative b and the positive b, these cancel out. 2/3 and 3/3 is 5/3. Absolutely, Sophia. Audrey, what do we want to do now? Yeah, minus 5 from both sides. Oh, no. Sarah, you're going to get the toughest question that we've had in class so far today. If we have a fraction multiplied by our variable, how do we turn it into just 1b?
Multiply by 3/5.
Yeah! Way to go, Sarah. We multiply by the reciprocal because a fraction times its reciprocal equals 1. This step right here is what people often try to do in a weird way or try to make more complicated than it needs to be. Sarah said we're going to multiply by 3/5 because that would make 15/15, which is 1. But we know we can't just do it on one side, and if I'm going to come do it on the right side, I should make this into a fraction first. So make 15 into a fraction. I got to end it for you. So you're good now. You're back, and it's coded that you're back. So when we go to multiply by 3 over 5, now I can do this multiplication, or if you remember how to cross reduce, you can. I'm going to color code this in 2 different ways. In green, I'm going to just do the math. 5 times 3, 1 times 5. That would be 45 over 5. Gets us 9. In pink, I'm going to show cross-reducing. To cross-reduce, and guys, I call it top-bottom reducing. If on top and on bottom, we can divide by the same thing, we can do it at any point. So right now, I could divide by 5 on bottom, and I could divide by 5 on top. So sorry, that's a division symbol. Divide by 5. Divide by 5. This would become 3 over 1 times 3 over 1. Oh, well, that's convenient. And we get the same answer that we got. So it doesn't matter if you cross-reduce. It is just a shortcut method that you can take. By the way, guys, when I do that weird thing with my hand, it's to get the camera to focus again. Graph paper confuses the camera, so sometimes it gets thrown out of focus. I like do this to make the camera like lose focus and then but now it's locked. Now it's got focus on lock. So 1b is just 9. Nothing complicated, no fraction value, decimal value, anything like that. 1b is 9. Any questions on this solution? All right, so obviously Cooper and Charlotte, you guys got to be ready for me throwing questions to you, and then we'll start the loop over again. We'll probably just go straight back to Charlotte and then over to Cooper. So for this next problem, Oh yeah, Zoe, you got to be ready for me to throw a question at you. No, we jumped to Colin right after Logan. Sorry, then I had to go back to... Colin raised his hand and messed everything up, but it's okay. I'm just teasing. All right, try this one, guys. Try this one. All right, it's positive. I had to double check that it was positive because I could not see it on my screen. Positive 4.5 plus positive 1.5k equals 18 and negative 3k. Now, notice how I said 18 and negative 3k. When you write it, yes, it is. When you write it, hey, Logan, can I ask a favor? Quit making me tell you you're wrong. Just sometimes think about what you're going to say before you say it, because I think you would catch yourself like 50% of the times. Minus is negative. So instead of saying 18 minus 3k, we can say 18 and negative 3k. And I'm going to write it like that. So I know you can't see what I'm writing right now. That's on purpose. My k's look a little bit weird. Get over it. I love you guys, but now I'm just really honest with some of these things. I'm tired of kids being like, why does your K look like? Because my handwriting's weird. I also had a speech impediment when I was a child, so when I get tripped up on my words, that's why. The fact that I can speak as well as I do now is a huge, huge thank you to speech pathologists, which are like the people that work with people with a speech impediment. So Logan, just to make you happy, I went ahead and wrote it how it is, and then I'm going to change how I have it written. So I copied down the problem exactly how it is. But how I said it was and negative 3k. Because minus a positive, which is what we have here, minus a positive, is technically the exact same as add a negative. So we know this k value is actually negative, and this k value is positive, so it wins, right? When we think through step 1, which, guys, I still have my steps up here, right? So step 1, choose a side for the variables. Highest value works well. So we've got highest value, right? The left side is our highest value. How do I get rid of a negative 3k? Add 3k. Sorry, we'll go whole group on that, and then Zoe, because I accidentally skipped you last time, on the next step, we're going to call on you for what we do after we rewrite this now. So we get 4.5 plus 4.5k, interesting, equals 18. So, all right, Zoe, you able to tell me what we do next?
Subtract 4.5 from each side.
Yeah, we subtract 4.5 from each side because we want to get it off of the left-hand side. We decided this is our variable side, and this side will be our constant side. Because really, in the end, you want your variable equal to a constant, right? That's what we're trying to make happen. So we subtract 4.5, Zoe said, from both sides. Got to make sure we do both. I'm going to break this. Do minus the 4, then minus the half. So minus the 4 gets 14. Then minus one more half gets 13.5. I like that whole break up the math strategy. I think it makes things a lot easier. Charlotte, what do we do now? Yeah, you did, because that's the right thing to do. What'd you say? Ooh, throwing down. Cooper said, what if we, sorry, Ivan, I get you guys switched to my name, cause, like, and on my seating chart, you guys are literally like this. Like, because you guys sit there and there. Okay, whatever. My bad. Ivan, we miss you. Cooper, you're awesome. So Cooper said, if we double, what if we take the whole thing, and I'm going to write this in a different color because this is a whole different route. So Cooper said, you know, if we double this whole thing, we get 9k equals 27. Now, you made sure you doubled this one, too. So then we could just divide by 9 and get k is equal. What's 27 divided by 9? 3. Yeah. That's the same thing we would get up here. K will equal 3 when we do this division up here. So, Cooper, you brought up a really good point that is almost like a better segue than I could have even planned. And I'm going to skip the last problem that we have here because of your perfect segue. So, notice what is up here is different. Read the board for a moment. So now we're solving when parentheses are involved. There are two options. And this is why math at this point gets really tough. There's options for everything. So the two main options, there are probably more than two options, are to go ahead and distribute the multiplication and then solve. Or, kind of in like a Cooper thought process, is there a way to make it easier and just do it the easier way? So that easier way involves only if it is easy, right? So I was just making sure I could see everything it said. When I look at 6 being the object that needs to multiply, what I'm asking when I think about step 2 is, could I divide by 6 on the other side as well? And that would be really messy, right? So here, option 1 is going to be our correct option. So let's all write this down. I'm going to try to keep switching colors so when people are watching the video. So 2 minus 16t equals 6 times the quantity, is how we say that. 6 times the quantity, negative 3t plus 2. Here's the trap door. Your brain is really good at identifying that these need to multiply. Your brain is really bad at remembering that also these need to multiply. Because 6 is multiplying by everything in here. not just the negative 3t, it's multiplying by everything in the parentheses. So guys, I always draw the arrows. I always draw the arrows because it activates a part of my brain that says I have two things to do. And guys, there's tons of research. When you go to college, it's really fun when you get to start reading about research people have done. And like we start to do that now, but especially college because it's what you want to do. The physical picking up of a pen or pencil or whatever and drawing something, it literally like triggers something in your brain that helps you learn and helps you think, right? So by drawing these arrows, it's literally giving my brain a moment to say, I have two multiplications to do. The left side, I have nothing to do, but my right side, the two things I have to do is 6 times a negative 3t. That's the one thing I need to do. And also 6 times 2. The dangerous part. Watch out for the sign in between the terms. If this is a minus, we really want to treat it like a negative. And when we do the multiplication, remember, the minus would go with that second number. So if there's a minus there, it goes with the 2. There's not in this case, so we're happy that there's not. 6 times negative 3t, negative 18t. 6 times 2, 12. Which side has the higher variable? Sophia?
The left side.
Why? What's the value of the variable over there? Yeah, and sorry, I shouldn't have said the value of the variable. I should have said the coefficient of the variable. My bad, that's on me. The coefficient of this variable is negative 16. Not 16, it's negative 16. So be careful. If you left this written as subtraction, we need to at least be thinking this is really negative. So when what are we going to do on both sides, Sophia? Yeah, add 18t, because that will make 0 right here. And on the left-hand side, what's negative 16 plus 18? Well, it gets positive. It's 2. Positive 2. Any questions on what we did through the distribution? And if you want to make a note, what we did here was distribute. What we did there was distribute. Then we used our inverse operations. The last thing I want to do on both, well, not the last thing. Thanks, I was going to say class, but okay. Yeah, like Logan said, we subtract 2. Fine. Class, the actual last thing we're going to do. I like how Colin then raised his hand. Well, I didn't know you were raising your hand or just pointing, like, onward. Yeah, we divide by 2. Charge! T equals 5. You called it? When exactly did you call it? Did he actually? Okay, I'll let it slide. I mean, you're allowed to. Fine, since all you want to solve it on your own, try this one. I don't care. Look at this face. Does this face care? I know. Well, then you should probably just do it. Did you already do all the Khan Academy?
Not all of it, but I did a little bit.
I was about to say, these are straight up from Khan Academy. So if you guys have these written down, only 4 of you have done these assignments so far. I am writing all over my hands. So if you're one of the people that hasn't done the assignments yet, these problems are in those assignments. I don't guarantee all of them are.
I used to just write down everything that I got wrong or that I got right, so then
Sebastian, what do you got to say? I don't want the answer. I want the process. Do you have the process? Let's talk about the process. So did you choose option 1 or option 2, Sebastian? Did you distribute or did you divide both sides? You distributed? I'm going to show both. Yes. It is both. But it's not both at the same time. It's only one at one time. So, Sebastian, you said you distributed. If I'm going to distribute, I draw arrows. And guys, really, they're not arrows. They're just lines. 8 times 10, 80. You can make it an arrow if you want to. Minus, or, I'm going to go ahead and say plus negative. 8 times negative k gives me negative 8k equals 2k. Like 2k sports. Now, hold up. If I go the division... Nah, we'll come back here. I don't want to go back and forth. That might confuse me. So, what do I want to... We'll just go class answers on this. What do I want to do now? Ooh, careful. Add 8k. Ah, you're funny.
No, I was actually about to say 8,000.
So, we got k equals 8 over here. When I look at this, here, guys, I'm using this as a segue problem. I need your focus, please, especially those of you watching the video. Please give me your focus because this is our segue problem. This solves perfectly fine, right? No issues, no problems. But what if I don't want to do the distribution? Well, the opposite of multiplication is division. So if I divide by 8, this just becomes 1 times the parentheses. Guys, this doesn't divide because the entire numerator's one term. It's not split up multiple terms. It's one term. So when this divides, it literally just becomes 10 minus k. But I cannot just divide on the left side. So to do this, we have to be able to divide on the right side. And that gives us a 4th k. Guys, I'm not saying this is the best way to go. I'm just showing you an example. Now, we could add a k, right? So to get rid of this k over here, we can add a k, which would be adding 4/4 k. So yeah, 10 equals 5/4 k. I don't really think this way's better. It works, because now what would I multiply by to get rid of 5/4? Yeah, it's reciprocal, 4/5. And if we do that over here, we get 40 over 5. Which is 8, but it actually took me more steps. This was not a better option. It was an option, but it wasn't better. Let's look at a situation where option 2's better. Check this out. So let's go ahead and write it down. Sorry, I shouldn't start talking before we have a chance to write it down. Yes, absolutely. That's why I'm just leaving the drawer open so you guys can just grab when you need it. The question we should be asking ourselves when we're deciding between option 1 or option 2 is it nice if I do option 2? Now, the fraction that we just got wasn't bad, but it wasn't necessarily nice. Like, it wasn't like a whole number, right? And it didn't work very well. Like, we could have thought through this and said, man, we don't really like that. But what if we try over here to stop a multiplication by 3, we divide by 3. And we could draw the division line to be across the whole thing. Don't let that confuse you. We do not do anything inside the parentheses. This just becomes 1. And we divide by 3 over here. Is this nice? Yeah, it's really nice. It's just 3G. And then the left side, this becomes 1. So I just get what was in the parentheses. -4 plus 5G. Now, here's the weird thing. If you follow my advice and you use the higher value of the variable, we're going to subtract 3G. Right? Because the higher variable gets that side gets the variable. Wait, that gives me 0 equal to -4 plus 2G. My G's also look weird. You can make fun of me in your head, but I don't really care. My G's just look weird. Then we add 4 to both sides. Huh? Wait, I heard a wait.
I mean, it works. It's just really, that's not the way that I did it, because I did not like that.
4 divided by 2.
I didn't go to the 0.
So, here's the other option. Right here. Instead, this is a moment when you can use your brain. Oh my gosh.
Oh my goodness.
This -4 is the only constant we have. Give the right side the constant. Just go ahead and leave it there, which means the left side can get your variable. We did the opposite over here, right? We did variable side over here, constant side over here. So leave this alone. How do I get rid of a 5G? Subtract 5G. That's how you stop up your plumbing when you try to flush things that shouldn't be flushed. What is 3G minus 5G? -2G. Dude, just shout it out. You don't need to wave your hand and do that. Just shout it out. So now what do we want to do? Just be careful. This is why I'm cautious about going this way. We divide by -2. And a negative divided by a negative will get a positive. So we get G is equal to +2. So that's why back in our steps, I said highest value works well, and I should have said most times.
You did on the last slide that had it.
On the first one?
On one of them, it said, there's that one.
Yeah, there's certain things that don't always work, right? Certain rules don't always work. So here, the equation we're looking at right here, with this work, dividing on both sides worked, right? Dividing on both sides worked. It made things easier. But then, step 1 didn't really make sense. It works. It's fine, but it's actually a waste of a step. Whereas over here, if we just use our brain, makes more sense to just deal with a negative variable in this one. Let's try at least one more. Try this one. I will tell you, you should take option 2. I will tell you, you should take option 2. -4n. I'm going to write plus -8, but that's up to you guys. So instead of writing -8, I'm going to do plus negative. So I will go ahead and show my screen since I'm telling you to take option 2. Option 2 would be we divide by 4. Again, there's a trap door. Because this division by 4 is going to happen to 2 different pieces. So when we divide by 4 on the right side, guys, this is one term because the multiplication and this is all held together in the parentheses. So this division by 4 just happens right here. But on this side, it happens in both places. So I'm going to color code this a little bit just to help people. This becomes negative 1n. Or just negative n. This becomes negative 2. And the right side, well, if this became 1, then it's just negative 3n plus 2. Any questions how I got these values on the left side? So, now, I'm going to rewrite it all in the same color. Negative n plus negative 2. Yeah, so I heard the question of should we add 3n? This one, the negative n is the most positive, even though it's not positive, it's the most positive. So if we add 3n on both sides, this will turn into 0. Negative n plus 3n. 2n. Colin, what are you saying is a trap? There it is. He caught himself, ladies and gentlemen. So we have 2n, not 3n, right? Negative n plus 3n is 2n. So 2n is equal to 4. Now, even if this was 0, because some people are tempted to say, like, oh, minus 2 and 2 is 0, it's still a number. Like, we can work with 0. So even if we got 0 on this side, that's fine. We could still deal with that. But I ran out of space, so let's come over here. If 2n equals 4, what do we do then?
Divide by 2.
Thank you. We divide by 2. And n is?
2.
As always, if we want to check, plug it back into the original.
But do we want to check now?
Not right now. No time.
Did it?
Now, option 1 would work. I'm not going to do it, but if you distribute, it would work. Like, that's fine. Option 1 always works. Option 2 is just an option. You don't have to take it. And that's everything I had planned today. Look at that. We got 3 minutes left. All right, so at home, people. Well, not at home. You'll be at school when you're watching the video. But by the time you watch this video, the Desmos activity will be up and live. So it's assigned to you if you go to desmos.com and go into your like student homepage, I think they call it on there. You'll have it there. It's available for you. Aside from that, just please make sure you got all the notes down, and then I think you're good to go. So for the rest of the time, do Khan Academy or Desmos or whatever you want. I'm going to stop this recording because now it's just going to get awkward.